Hello and welcome to this training session on troubleshooting data ingestion in Snowflake. We will focus specifically on how to identify the root causes of ingestion errors across different loading methods. To effectively troubleshoot, we first need to define what we are looking for. Ingestion errors occur when the data payload fails to commit to your target table. We categorize these into three main buckets. First, parsing errors happen when Snowflake cannot read the file structure. Think of a CSV file where the delimiter is wrong. Second, validation errors occur when the structure is fine, but the data itself is invalid, like trying to load text into a number field or violating a not null constraint. Finally, configuration errors usually involve permission issues or missing stage objects. This flowchart visualizes the ingestion path. Data moves from the source to an ingestion attempt. If successful, it lands in the target table. If it fails, we branch into our three categories. Parsing errors where the format is wrong, validation errors where the data content violates rules, and configuration errors often tied to access controls. Understanding which path your error takes is the first step in troubleshooting. Now, let's look at why these errors happen. A frequent culprit is a file format mismatch. If you define a CSV format expecting a comma delimiter but the file uses pipes, the load will fail or load garbage data. Data quality is another major driver. For example, invalid UTF-8 characters can halt a load unless you specify replace invalid characters. Also, consider schema drift. If your source sends new columns but your table isn't set up to evolve, ingestion might break or ignore data. Finally, always verify access control. A missing usage privilege on a stage will prevent access before data processing even begins. This mind map breaks down the root causes you should investigate. Under File Format, check for delimiters and compression settings. Under data quality, look for type mismatches and constraint violations like null in non-nullable columns. Under configuration, check for missing privileges or dropped stage objects. Keeping these categories in mind helps narrow down your investigation quickly. For bulk loading, you have powerful tools to identify causes. Before loading, you can run copy into with validation mode set to return all errors. This simulates the load and reports every error found without modifying your table. For loads that have already failed, don't rely solely on the simple status message. Use the validate table function passing the job ID of the failed load. This function returns every error encountered, not just the first one, giving you a complete picture of the data quality issues in that batch. This sequence shows the troubleshooting workflow for bulk loads. First, proactively use validation mode to catch errors early. If a load has already run, check the copy history for the status. If you see a failure, follow up by calling the validate function with the job ID to extract the specific error details required for fixing the issue. Troubleshooting Snowpipe requires different tools because it runs in the background. Start with system$pipe status to see if the pipe is running or stalled and if files are pending. If files are failing, use the validate pipe load function. It works like the standard validate function but scopes results to a specific pipe and time range, revealing exactly why files failed. For proactive monitoring, configure error notifications to push alerts to your cloud provider's messaging service whenever a file is skipped due to errors. This state diagram guides your Snowpipe debugging. Start by checking the status. If the pipe is stopped, review its definition or upstream stage permissions. If it's running but data is missing, check the copy history. If you find failed files, transition to using validate pipe load to extract the specific error messages associated with those files. For Snowpipe streaming and connectors, the approach shifts to channels and logs. For streaming, query the Snowpipe streaming channel history view or use the SDK's getChannelStatus method to see error counts and messages. If you are using the Kafka connector, look for records sent to the dead letter queued DLQ. These are messages that failed parsing or schema validation. For native connectors like Google Analytics, Snowflake provides built-in views like connector errors directly in the connector's database to log specific ingestion failures. This diagram classifies the troubleshooting sources for streaming and connectors. Streaming ingest relies on channel status APIs and history views. The Kafka connector utilizes dead letter queues for bad records. Native connectors expose dedicated stats and error tables. All paths ultimately lead to detailed error details that help you resolve the issue. To wrap up, effective troubleshooting follows a cycle: monitor, identify, validate, and resolve. Always monitor your load history and set up alerts. When an issue arises, identify the specific file or job ID. Use Snowflake's validation functions to get precise error locations down to the line and character. Once you fix the root cause, whether it's the data, the schema, or the configuration, you can retry the load. Remember, for pipes, use alter pipe refresh to retry modified files if necessary. This final process flow summarizes your troubleshooting strategy. Start by monitoring logs and views. When you detect a failure, identify the specific job. Run the appropriate validate function for your ingestion method. Analyze the returned error message to understand the root cause. Fix the data or schema, and finally, retry the load to ensure success.